When we were doing solving radicals, we came upon just a couple of problems where you were trying to have the square root of a negative number, correct? Okay, and I told you at that point that we did not know how to do the square root of negative numbers. So this section comes up with a new plan. Actually, it was invented by this guy, Gauss. He said that, well, I'm going to make up a imaginary number system where I have the letter I equal negative one, square root of negative 1, and I squared is negative 1. Now you can solve all kinds of radical problems. For example, number 1, I have the square root of negative 9. Well, I can actually rewrite this as the square root of 9 times negative 1. And then I can split up my square root to the square root of 9 times the square root of negative 1. Now, I can take the square root of a negative number. Negative 1 is what? I. This is square root of 9 is 3. My answer is 3i. Now, I is an irrational number, so it always goes and back to the rational number. Make sense? Of course it does, Mr. D. Oh, that's cool. All right, number 2. Number 2, I'm going to split this up to 6 times negative 1. And I have split up the radical, square root of 6 times the square root of negative 1. And the square root of 6 is going to stay that way. I can't simplify it. And the square root of negative 1 is I. I goes before the square root. Well, let's think about that for a minute. Okay, I'm going to change this to, you're right, I'm going to have a square root of negative 1, right? Now, the square root of 8. We can simplify that, can't we? What can we break that up with a perfect square as a factor? 4 and 2. So I'm going to put my square root of 4 over here, my square root of 2 there. And I'm going to show you why I'm doing that. Because when I take the square root of 4, I get a rational number, 2, and square root of negative 1 is I. Then I have my square root of 2. Do you see the order of that? Rational number, irrational number, and then my irrational square root. Number 4. Let's do the same thing. I have a negative 1 there. So that's going to be a square root of negative 1. Let's think about the factors of 32 here. 4 and 8, 1 times 32. I have 4 times 8. Any others? 2 times 16. I do have a bigger perfect square, right, than 4. So I'm going to break this up to the square root of 16 times the square root of 2. Square root of 16 is 4, square root of negative 1, I, square root of 2. Yes, and the order matters as far as rational numbers, I, and irrational numbers. Pretty easy, right? Okay, that's simplifying radicals with negative numbers. Now we're part 2. It's going to be dealing with solving negative radicals. Doesn't really get difficult until we multiply and divide is the funnest. Funnerest. Okay, part 2. We're solving. The first thing I have to do, I have to get the x squared by itself. So the first thing I'm going to do, that's right, subtract 10. Okay, so I get 3x squared equals negative 36. Divide by 3. So x squared equals negative 12. Now what? Square root both sides. I get x. Okay, let's simplify this a little bit. Yeah, which one has perfect square? 3 and 4. So I'm going to put my perfect square first. Square root of 4, square root of 3, and then my I is going to go in between them, right? Now, be careful here. We're solving an equation, so we need our plus and minus, right? Okay. Now, that's going to go after our rational number 2. Then I have my I for the square root of negative 1. Nothing I can do with the square root of 3. So there's my order of things. Just like English, you can't say ain't no good, right? It ain't not no good. You gotta have it in this order. Okay, number 2. Let's get the x squared by itself. Subtract 26. I get 2x squared equals negative 36. We're going to divide both sides by 2. Yeah, I got a bunch of them for you right there. No, not right now. Because I'll pass them out. No, not right now. I'm busy. Jeez. X squared equals negative 18. Okay, square root both sides. It's already been done by my 3rd hour. Don't worry about that. I think Riesel did a good job. All right, square root of 18. What am I going to use? 9 and 2, right? Square root of 9 times the square root of 2. Then I have my square root of negative 1. So x is going to equal plus or minus. Oh, let's put our rational number of 3. Yeah, we got to put our 3 first. Plus or minus I square root of 2. Okay, number 3. I don't like fractions. How do we get rid of fractions? Multiply both sides by the reciprocal, right? These cancel the 1. 1 times quantity x plus 1 squared is x plus 1 squared. 5 times negative 2. Negative 10. Now what? That's right. Square root both sides. So I get x plus 1 equals plus or minus square root. Oh, there's not much I can do with the square root of 10. I can take out the I, right? Yeah. Now what? Gotta get x by itself. Subtract 1. So x is going to equal -1 plus or minus I square root of 10. Questions, comments, concerns? Nope, we got to do adding, subtracting, multiplication, and division of it. And adding and subtracting isn't hard. Multiplication gets a little hard. Division's hard. All today, my man. All right, number 11. Here we are with addition and subtraction. Now, addition problems is easy, right? Just drop the parentheses and combine like terms. So I have 4 minus I plus 3 plus 2I. Combine like terms. My rationals, I have 4, 3, 7 plus 1I. There you go. Minus I plus 2I is a plus 1I. That was easy. What do I do with the minus sign? Remember, it's a -1, right? I have to distribute over the parentheses, right? So I have 7 minus 5I. -1 times +1 is -1. -1 times -5I is a +5I. Combine like terms. 7 minus 1 is, what happens with my I terms? Let's see if 13 is funner. Looks funner. Okay, here's a -1, right? I have to distribute. Okay, so I get 6 minus -2 is a +2. Negative times positive 9i is -9i. Plus a -8 is -8 plus 4i. Okay, let's combine our real numbers. 6, 2, -8. Hey, what happens? Then my -9i, positive 4i, so -5i. Still pretty easy, right? Get some funner stuff, multiplication. As Bob Sager would say, turn the page. Okay, I have to distribute 5i. 5i times -2, -10i. 5i times plus 5i squared. Now remember, I equals the square root of -1, and I squared equals -1. What am I going to do here? I'm going to substitute in -1 for I squared. So I have -10i plus 5 times -1. So I get -10i minus 5. And please don't remember the ain't, not, no. You got to put it in right order. So -5 minus 10i is our proper order. Rational number first, irrational second. ¿Comprendes? 15. 2 times 22. 2 times 11 is 22. 2 times 16i. Wow, this is easy. Okay, 3i times 1. 3i minus 15i squared. Yeah, all you're going to do with the I squared here, you're just going to change the sign, right? Because you're multiplying it by negative 1. Negative 15 times negative 1 is positive 15. Careful, that's positive 3i. Now we get a little bit more funner. We have a binomial times a binomial in 17, right? What are we going to use? What do we use when we multiply the in or out thing? FOIL. We're going to use the In-N-Out burger. FOIL. Okay, you ready? Are you ready, kids? Okay, 7 times negative 1. First, 7 times negative 1. Negative 7. Outer, 7 times 2i. 14i. Inner, negative 4i times negative 1 is a positive 4i. And last, negative 4i times positive 2 is negative 8i squared. Huh? I just used FOIL. That's all I did. What did I lose to in the FOIL process? First, 7 times negative 1 is negative 7. Outer, 7 times 2i is 14i. Inner, negative 4 times negative 4i times negative 1 is a positive 4i. And last, negative 4i times a positive 2i is a negative I squared. I just FOILed it. That's all I did. Okay? Yep. Now, when you use FOIL, you're always going to have the middle term to combine, right? So I have negative 7, positive 14i plus 4i is positive 18i. And what happens to my minus 8i squared? Yeah, so it just becomes positive 8, right? Negative 1 is my I squared times negative 8, positive 8. Combine your rational numbers, negative 7 and positive 8 gives me a positive 1. And I have 18i left over. Are you okay, Pat? Patrick? Patrick! You got his headphones in now? Or is he just completely ignoring me? Patrick! Are you okay now? Are you good now? All right. Okay, I have a binomial times a binomial. 6 times 6 is what? Outer, 6 times negative 3i. Inner, 3i times 6. And last, 3i times negative 3i. Okay, look what happens to our middle terms here. Okay, what does this negative 9i squared end up being? Positive 9. And I have my 36, 45. $19. I'm going to rewrite so I can FOIL it easier. Easierest. 3 plus 4i times 3 plus 4i. You don't have to, but I would prefer that you do so you don't make mistakes. You two have some issues. No, you two. Okay, 3 times 3 is what? 9. Outer, 3 times 4i. Inner, 4i times 3. I didn't touch it and just restarted on its own. Maybe it needs juice. 4i times 4i. 16i squared. Yep, that's what it is. Okay, combine middle two terms. Okay, so we have a 9, we have a minus 16 plus 24i. They don't cancel out, they don't have different signs. What's 9 minus 16? And then I have my 24i. Questions, comments, concerns? All right. Number 20, division. Yeah, this is the harder. I like to think of them as the funner stuff. You can never leave, just like radicals. You can never leave I in the denominator. So what you're going to do to get rid of the I terms is you're going to multiply it by what's called the conjugate, which is nothing more than changing the sign in between the terms to the opposite. So this one's minus, I'm going to make it a plus. But, of course, you can't just multiply the denominator by that. You have to multiply the numerator by it, too. Okay, FOIL the bottom. 1 times 1 is 1. Outer, 1 times 2i is 2i. Inner, negative 2i times 1 is, and last, negative 2i times positive 2i is negative 4i squared. Look what happens to our middle terms. Yeah, when you multiply two conjugates together, your middle terms always go away. Yep, this is positive 4. So I have 1 plus 4 is, that's my denominator. See how easy that is? Now, the numerators get a little tough. Not tough, but funner. More funner. So I'm going to multiply 5 plus 3i times 1 plus 2i. So first, 5 times 1 is outer. 5 times 2i. Inner. 3i times 1. And last, 3i times positive 2i is positive 6i squared. So this becomes negative 6. This becomes positive 13i. And I have my 5. 5 minus 6 plus 13i. It's funner. It's longer. It's more longer. Longerous. Well, you guys are catching on with the language thing. English 12? Really? I don't believe you. I think you're in English 8. Okay, multiply it by its conjugate, which is 1 minus I. I don't think so. Okay, we know that the middle terms cancel, so all I need is the F and O. 1 times 1 is 1. Negative I, or I'm sorry, positive I times negative I is negative I squared, which is just negative 1, right? So I get 1 plus 1, because it's the opposite, which is dos. You with me? Did I go too fast? Did I do too many shortcuts? Yeah, what? Oh, that was Nate? Yeah, right. Okay, first, 2 times 1 is 2. Outer, 2 times negative I is minus 2I. Inner, negative 7I times 1 is minus 7I. And last, negative 7I times negative I is positive 7I squared, which becomes negative 7. Combine your two like terms here in the middle. Minus 9i. Bring down your 2. 2 minus 7. 2 minus 7. Negative 5. Minus 9i. Yeah, but when they're going to cancel out, because that's what conjugates do. Okay. When you multiply two conjugates together using the I term, you will always get a number. That's why we do it, because you can't have I in the denominator. So we do 22. All right, multiply by 3i over 3i. Did you? 3i times 3i is 9i squared, which is negative 9. Now here we're just going to distribute, right? 3i times negative 2 is negative 6i. 3i times positive 5i is positive 15i squared. Don't forget we're taking the opposite. So this is going to be negative 15 minus 6i. Yeah, let's do this electricity word problem here. Okay, I want you guys to pay close attention. Are you ready? Electrical circuits contain several components: resistors, inductors, and capacitors. Overall resistance is impedance Z. Overall impedance can be found by adding all of the components together. Each resistor is a real number R, each indicator is a pure imaginary number Li, and each capacitor is pure imaginary number minus Ci. So we can use the following formula to find the overall impedance. Hey, that's juvenile. So we're supposed to use this formula. No, delinquent. Find the impedance of the series circuit that has the following components. Resistor. So we're supposed to find Z. Z equals R, which is 6 ohms, plus Li, what's L? Inductor, so 10, and Ci is the pure imaginary number 5. Are we supposed to use the I's in this? I don't know. Are we supposed to have an I there? I think we're supposed to use the I's. Okay, so I have 6 plus 5I. If we don't use I, it's just going to be 11. No, looks good. I'd have to look it up. I don't remember. Yes, it's on one of your finals. Let's see. Z equals resistor is 13 plus 4I plus 5I minus 7I. So Z is going to equal 13 minus 2I. I'm assuming we have to use I since, this section. Questions, comments, concerns? Wonderful. Do your bookwork. What's your bookwork? What's your bookwork, you ask? Well, your bookwork is page 253, 8, 9, 12, 18, 19, 22, 24, 28, 31 operations. Page 253, number 39 through 43, solving with complex solutions. Huh? It's on your note sheet. Cover sheet. Questions, comments, concerns? No. Wonderful. I don't remember. I doubt it. Yeah, it's been a while. Let's start here. What do you have? Oh, that's awful. How come it's so bad? What's I to the first, people? What's anything to the first? I. What's I squared? -1. What do you think I cubed is going to be? What's I to the 4th? What's I to the 5th? What's I to the 6th? What's I to the 7th? I to the 8th? Do you see the pattern after a while? After squared, it's -1, positive, negative, positive, negative, positive. Pretty easy.